In this video, we're going to split a mold cavity and core using surfaces. We're going to get a little more sophisticated than we were in the previous video where we used just solid features. In this case, we're going to use all surface features. We're still not going to use the SolidWorks mold tools. You can use those if you like. It's a very specific process that they make you go through. And there is almost always a point in their process where the automation breaks down and you have to start doing things manually. So you have to understand what I'm going to go through here in order to really finish up the SolidWorks automation tools. We're going to add a layer of difficulty to this by adding some screw bosses to the mold so that the two halves of the rubber ducky can be screwed together. Let's roll everything back and see how this was done. We start from the same place that we started from before. Just the plastic rubber ducky with a little panel cut out of its back end. So in this case, we're going to not do things with solids. We're going to do it all with surfaces, which is the way you have to do it in more sophisticated plastic parts. So I start out by scaling up the rubber ducky. You have to be careful when you're scaling up plastic parts. If you're using reference planes in your model, sometimes part faces can move relative to those reference planes. So it might be more wise to just use model faces as the parting line rather than reference planes, unless the reference planes were created after the scale feature. Scale feature has a couple of options, and the big one here is what are you going to scale about? In this case, I've chosen the scale about the origin, and the origin should sit right on this plane. So in this case, my reference planes are going to still be good, but just out of safety, I'll keep using this top face as the reference for the parting plane. Now, I said I wasn't going to use solids, but I kind of lied. So I'm going to start out by making a couple of screw bosses, and then I'll make some more of them, distribute them around the model. Notice that these are created as separate bodies, and I've used an indent feature, which is a very cool SolidWorks feature that allows you to take, in essence, a tool and indent a part with the material around it. So that if we look at this, the plastic up here is thicker than the tool that was used to create it. So it's like these parts were punched, and now we have the screw bosses, and the draft just comes at the back end of the rubber ducky just to draft those surfaces. We've added some more fillets and some more draft just to make things a little more realistic. Let's go up here and turn off these screw boss indent tools. While we're doing that, let's take a look at the indent tool itself and see how that works. You've got the target body, which is the rubber ducky. You want to keep the selections, keep the things that you select, or you could choose to remove the parts that you select. This option depends very much on what is easiest to select. Sometimes there are things that are obscured and it's easier to select parts that you want to get rid of. The tool body regions were just points on the bodies that I had shown previously, and the parameters down below are for the thickness of the material that it adds, in this case just a 0.1 inch. So that's the indent tool. You have to create separate bodies as a tool, and then it will punch out the material to a certain thickness. And now's where the real surfacing work starts. One of the tools that SolidWorks has added pretty much exclusively for the mold creation is the surface Radiate. You can select any sort of a 3D edge, and SolidWorks will radiate a surface given some sort of a reference plane from those edges. In every case here, we've selected the parting edges of the rubber ducky all the way around, even where it's 3D. And in some places, it can get kind of funky, as you'll see here. This tool isn't 100%. And what it's doing right here is just weird. It's nothing that we can really work with. So what I've done is I've made use of the rest of the surface, but I deleted these particular surfaces back here because they weren't doing exactly what I want them to do. And you might find that in your models, especially in non-planar parts of the parting line. From here, I created a planar surface that was essentially just like the Radiate surface, but a lot bigger, and it encompasses most of the parting surface that we're going to use to split the mold. And from here, we created an extrude. You can see I've got a sketch, and the extrude just goes probably from this area up to the body of the rubber ducky. And then all of that is knit together. Okay, so this is more realistic about the way that your parting surface is going to look at the interface between your cavity and core blocks. From here, I use a boss extrude to just extrude right through everything, a single solid block that goes right through everything. And then I use the split to split that single block using the surfaces that I've created into two pieces. I should mention that at some point back here, right here, there is a special property of the Radiate surface, and there is a reason why I use this even though it creates some funky geometry. If you knit together a Radiate surface, and then you pick a face on the inside, which is called a seed face, it will pick all of the faces on that side of the Radiate and knit them together. So essentially what this is a very quick shortcut to pick all of the faces on the inside of the rubber ducky and knit them together into a single surface. So that's just a special property of using a Radiate surface in the selections box of a knit feature. Okay, this is probably something you're not going to find documented, and not too many people know about this. But this is a function that's been around for ever since I think the Radiate surface came into being. Just remember that using a Radiate surface inside a knit surface enables this box called the seed face box, where you can pick something inside and SolidWorks automatically selects all of the faces on that side of the model. Okay, so that's what enables this surface to go all the way through everything and to split this block into cavity and core. But if we look at just the bottom block on here, I've still got my rubber ducky in here. What we have to do is subtract the rubber ducky. That's what we come down here to do with the combine feature, and there the rubber ducky is removed. And so if we go back up, and we can show the cavity and core side created with a knit surface, and we can take that knit surface. I always change my knit surface to yellow, or a lot of surface features I change to yellow if they're just in there as reference. And then you could try the other trick that we've done in the other video, where we extrude another block and we subtract the cavity and the core from it, and we should get the rubber ducky back. So this is a demo then of surface splitting the cavity and core from the rubber ducky using a couple of really cool tricks. First thing we showed is the scale feature. Second thing we showed was the indent feature. We also showed the Radiate feature, surface feature. From there, the really cool thing that we showed is the knit feature using the Radiate feature that allows you to get the seed face and automatically selecting everything inside. It's a huge time saver, especially for more complex parts. I hope you find this useful, and thanks for watching.